last but not least, we will talk about electron, not atom, electron. A number of electrons determines the chemical properties. So what do I mean by that? So you have a nucleus in the center of the atom, and then you have electrons surrounding the nucleus. You have several layers, you have several layers of electrons surrounding the atom. It is the outer orbit. The layer is the orbit, the outer orbit, the outermost orbit or the outermost shell of the electron that determines the chemical properties. Because when a chemical reaction occurs, usually it involves the transfer or sharing of the electron on the outermost orbit or outermost shell. So it is the sharing or transfer of the electron on the outermost shell that causes the chemical reaction. We'll talk more about this in the next few PowerPoint slides. So this is the point that we talk about. The number of electrons in the atom's outermost orbit determines chemical properties. The outer orbit, it has different names. Let me give you the different names. It can be called the shell, we call it outer shell, or the outermost electron shell, we can call it valence shell as well. Valence shell. And then so you have a nucleus in the center, and then the electron shell or the electron orbit that surround this nucleus, or you can call it the first orbit, the first electron shell, or the innermost electron shell or orbit. It can only hold 2 electrons. This is something that you need to memorize, 2 electrons. So after this first electron shell, then the next electron shell, it can hold 8 electrons. This is also something that you need to memorize. 8 electrons. And then the third electron shell, let me write it down here. So this is the first electron shell, and then the second electron shell can hold 8, and the third can also hold 8 electrons. So the first electron shell can hold 2 electrons, and then the second and the third one, they can hold 8 electrons. So is that clear? You need to memorize this. Yeah, it is important. And then the last point, I already mentioned that the transfer of electron affects the chemical properties. So one atom can either give or donate an electron, the other atom can receive an electron. The transfer of electron, giving or receiving electron, causes the chemical reaction. So let's take a look at the example of helium. Helium is an atom that has is an element that has two atoms and two neutrons. Of course, it also has two electrons in the first electron shell. And it says that the cloud shows the probable location of electron in the helium atom, meaning that electrons, they are surrounding the atom, but they move in this orbit randomly. And only the darkest part has the highest probability that they can stay. You can find the electron in the darkest part. And the circle is the electron orbit, representing the average location of the electron. Subatomic particles, as I mentioned previously, you have proton. Proton P goes with P, that is a positive charge. Neutron N goes with neutral, that means no charge. And then electron is negative charge. We assume that proton and neutron, they have the mass approximately 1. It is a round-off number, it's not exact 1. In other words, the nucleus has most of the mass. And we assume that electron has no mass. Well, in fact, the truth is that electron has mass, but it's just that the mass is very small. And location is the electron shell. So most of the mass of the atom is centered in the nucleus. So atomic symbol, you just consider carbon. We use the capital letter C to indicate it. And then at the bottom we put a number 6. Number 6 is basically the required atomic number. An atomic number is basically the number of proton in the atom of a carbon. And then number 12, it requires atomic mass. Atomic mass is basically the number of proton plus the number of neutron in the nucleus of carbon. So if you want to find out the number of neutron in an element, what you need to do is very simple. Just use the atomic mass minus atomic number. Then you get the number of neutron. And make sure you know the definition of the two, because I guarantee that I will test you in the exam about the simple addition or subtraction. Addition, basically I'll give you the number of proton and number of neutron, and then you tell me the atomic mass. Subtraction is basically I give you atomic mass number, atomic number, and then you give me the number of neutron. So this is a definition. You need to memorize those. Atomic mass equal to number of proton plus number of neutron. Atomic number is equal to number of proton only. So it should be very clear. Periodic table. So we have vertical columns. We call it groups. We have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and then group 8. And then we have periods. They are the horizontal rows of the periodic table. So let's take a look at, briefly take a look at the periodic table. Group 1, we call this alkali metal family. They are very reactive. Why? Because they have one free electron on the outermost shell. So hydrogen has one free electron on the first electron shell. Lithium has 1 free electron on the second electron shell. So group 1 basically it has 1 free electron on the outermost shell. Hydrogen has the 1 free electron on the first orbit. Lithium has 1 free electron in the second orbit. Sodium has 1 free electron. Second. Third orbit. Potassium has 1 free electron on the fourth orbit. If they lose this 1 free electron, meaning if they give this 1 free electron to another atom, then they will become stable. And because they lose 1 negative charge, 1 electron meaning 1 negative charge, then they lack 1 negative charge and they become 1 positively charged. We call this ion. That's why we have sodium plus one positive charge, and potassium plus. That's why the ion of sodium and potassium, they are positively charged, and it's only one plus. And remember, sodium and potassium, they're important for the nervous system. And then group 2. Group 2 meaning that they have 2 free electrons on the outermost shell. Oh, we call it alkaline earth metal, group 2. So for beryllium, it has orbit here. Yes, 2 free electron on the second orbit. Magnesium is third orbit, it has 2 free electron. And then calcium has 2 free electron in the fourth orbit. And that's why magnesium, after it loses 2 electrons, magnesium will become 2 positive because it loses the 2 outermost electrons. And calcium will become calcium 2 plus as well after it loses 2 negatively charged electrons. The third one, boron. Boron, we call it the boron family, the third group. They have free electron on the outermost orbit. So this is boron. Boron, you have free electron on the second orbit. You can see that 5 is the atomic number. That means it has 5 protons, and then that means it has 5 electrons. So 2 electrons on the first orbit and then 3 electrons on the second orbit. Aluminum, it has 3 electrons on the third orbit. This one I'm not sure what it is, but for aluminum, it is, when it becomes an ion, it is Al3 plus.